Okay, but so far what you have seen is an angle which can be shown like this, and you used to call this one, let's say, 30 degrees. Or you could draw it like this one, let's say this is 30 degrees. Okay. Now, from now on, we are going to change the way we define an angle and how we draw it, okay? The first thing we are going to put a constraint is that one leg of the angle has to be on the positive x-axis. So if this is your coordinate system, this is positive x and this is positive y, one leg of the angle has to be on the positive x-axis. So this is the first leg. Okay? This is what we call the initial terminal. I'm going to give you the definitions in a second. Now, the other leg, which is going to represent the angle, for instance, for 30 degrees, is going to be called terminal leg. And this angle is the 30 degrees. Now, in our new definition, if you turn or rotate counterclockwise like this one, this represents a positive angle. So this guy is 30 degrees positive. If you do the other way around, meaning counterclockwise, then the angle is going to be negative. For instance, this one, if I go like this, then it's going to be negative 30 degrees. We are not going to concern about negative angles, okay? I'm just telling you that if you go counterclockwise, it's going to be positive, otherwise it's going to be negative. But are we going to consider negative angles? No. We are just going to consider positive angles. And the angles that we are going to consider from now on, one terminal or one leg has to be on the positive x-axis, and the other terminal, which is called terminal leg, has to be somewhere, okay, in the coordinate system. And that angle between these two legs is going to represent the angle. Now, another definition that we are going to consider in this section is what we call a unit circle. Now, what exactly is a unit circle? As the name stands for, is going to be a circle with the center at the origin. Okay? And since it's a unit circle, the radius is unit, meaning that the radius is 1. This is 1, this is 1, and this is 1. Okay? All these are 1. Now, we use this unit circle to define what we call the reference angle. Now, if I want to show any angle here, I'm going to draw the terminal angle until it hits the circle at a point, let's call it x and y. Okay? So this angle, which we can call theta, has a terminal leg which cuts or crosses the unit circle at the point xy, which we call terminal point. So remember, this one is called the terminal leg, and this one is called a terminal point, x and y. Now, knowing from previous unit, this is going to be a right triangle because this guy is 90 degrees. Now, if I look at this, this is my triangle. I'm going to make it a little bit larger. This center is here. This is the point xy is here. So how much is this one, you think? If the point is xy, how much is this section here? X. How much is, let's say, this part? Y. Now, if this angle is theta, can somebody tell me, using trig ratios, what is sine theta here? What is sine theta in this triangle?
The inverse of the angle? Want to find the angle?
I want the sine of angle theta. What is the definition of sine?
Opposite
Over
hypotenuse.
hypotenuse. Now, if the hypotenuse here is r, I call it r. I'm going to define what r is, the radius. So what is the sine of angle theta?
R over Y.
Y over R. What is cos theta?
Uh, Y over X.
X over R.
Up and X.
Adjacent over hypotenuse.
Wait, oh, X over R, yeah.
Okay? Now, if you look at the sine and cos definition of the angle and the point, and this is a unit circle. If it's a unit circle, what is the radius? 1. So the sine theta becomes what? X over 1, which is what? X. If the radius is 1, what is? Oh, y over 1, which is y. And if radius is 1, what is x over 1? X. So this tells you that if you have a unit circle, any point on the circumference of the circle, the x value represents the cosine of the angle, and y value represents the sine of the angle. Okay, so let's have a unit circle, okay, like this one. I'm sorry?
This is an example?
Yeah. Let's say we have a point here, which is 3 and 4. Okay? Now, I know that if I draw the terminal arm here, this side is going to be how much? 3. And this side is going to be how much? 4. Now, using Pythagorean theorem, okay, if this side is 4, this side is 3, I can find the hypotenuse here. Agreed? Mm-hmm. So, this is my right triangle again. This is 3, this is 4. I can find this, which we call R. So I can say R squared is 3 squared plus 4 squared. Agreed? Now, 3 squared is what? 4 squared is? What is 16 plus 9?
25.
Now, if I take the square root of both sides, I get R is plus or minus 5. Remember, square root of any number is plus or minus that number. But you know that the radius, which is the length, cannot be negative. Agreed? Length is always positive. So this means that negative 5 is not acceptable. So we find that R is equal to 5. Knowing the radius to be 5, let's find this angle, the sine and cos of this angle. Okay? Now, which is this angle? What is sine theta in this triangle? What is sine? Sine theta. Opposite over hypotenuse. What is opposite here?
4.
4 divided by hypotenuse. Hypotenuse we just found to be 5. So 4 over 5. And the cos theta is going to be equal to adjacent, which is 3, over hypotenuse, which is 5. Now, what I want you to do is to use your calculator and tell me what is the inverse sine of 4 over 5, meaning what is the angle that gives you sine 4 over 5. So this one gives you theta is 53.1 degrees. Okay? If you use the inverse cos, try inverse cos and tell me what is theta of using the cos theta. 53.1. So it gives you the same angle. Okay? Okay, now going through the definitions here. Again, we are going to define initial R as the leg of an angle which is going to be on the positive x-axis. Okay? Meaning this angle has this arm on the positive x-axis. This is what we call initial R. Look at this guy. This guy has its initial arm on the positive x-axis. So from now on, any angle you draw one of the legs, which is the initial arm, has to be on the positive x-axis. So stop drawing, angles like this one. No, we are not going to work with these angles anymore. We are going to have one of the legs on the positive x-axis, and we call it initial arm. Now, we call the standard position of an angle to be an angle where one of the legs, which is the initial arm, is on the positive x-axis, and the other one is going to be rotated about the origin, which is going to show you the angle. This is what we call standard position. Like this one. It's showing angle 60 degrees. One side is on the positive x-axis, which we call initial arm. The other one is called terminal arm, which I mentioned before, which is this red one. Again, this angle, because it's counterclockwise, is positive, so it's 60 degrees. The other angle, which is going to go clockwise, is going to be negative. So counterclockwise is positive, clockwise is negative. The next definition is what we call a terminal arm.
Can you go back up a minute?
We define a terminal arm, which is going to be the second leg of an angle, okay, which is going to cross the origin, and we call it the terminal angle. Now, when the terminal angle crosses the circle, that unit circle that we talked about, we call it terminal point. And that's the point that has the xy coordinate that I showed you previously. Now, the terminal arm is the one which rotates about the origin. It's not the initial arm. That one stays stationary on the positive x-axis, but the terminal one rotates based on the angle which has to be represented. The next definition is the terminal point, as I said before, is where your terminal arm crosses your unit circle. In this case, point P here is called the terminal point. It has the coordinate x and y. Now, the interesting point about the terminal point, as I showed you before, is that the terminal point, x and y, are related to the sine and cos of the angle theta here. I can write that x over r, the radius, is equal to cos theta, and y over r is sine theta. Again, you may wonder why x over r is cos theta, because if I just redraw this triangle here, okay, this is angle theta, this is y, this is x, and this is r. You can see by definition, sine of any angle is opposite over hypotenuse. So you can see that sine theta is opposite, which is y, divided by hypotenuse, which is r, so y over r. And the cos is adjacent to this angle is x, so x over hypotenuse, which is r, so cos theta is x over r. Now, you may say, you mentioned something like a unit circle. Why suddenly we have, a circle of radius r? In a unit circle, radius r becomes 1. So you can see that in a unit circle, cos theta is x, and sine theta is y. This means that in a unit circle, this point, terminal point, is really cos theta comma sine theta. And that's the interesting part about the unit circle. The xy coordinate are directly related to the sine and cos of the angle. Now, the last definition for this section is what we call coterminal angles. Now, what exactly are coterminal? Are angles which are a multiple of 360. Okay? What it means is the following. Look at this angle, which is 30 degrees. If I take the terminal arm and rotate it exactly 360, where do you think I'm going to end up? I'm going to end up at the same location as before. And since we said that x and y represent sine and cosine, this means that the new angle, which is 360, plus the old angle is going to have the same x and y, meaning the same sine theta and cos theta. This is also true if I go clockwise, meaning instead of adding 360, I subtract 360 from this angle. Then if I go clockwise, I'm going to end up somewhere exactly on the same terminal arm. So I'm going to get the same angle. This is what we call coterminal angles. Coterminal angle for any angle is infinite coterminal angles out there. For instance, if I give you one angle, theta is 10 degrees, I can tell you that another coterminal angle is 360 plus 10, which is 370. Or I can say another one is 2 times 360 plus 10. Instead of going one time, I can go twice around the circle. Okay? So I'm going to get how much? 730. At the same time, I can go clockwise, meaning I subtract 360. So I can have 10 minus 360, which is going to be what? Negative 350. And so forth. I can come up with infinite number of coterminal angles here. Now, what is the formula that you can use to find the coterminal angles is given here. Beta, which is a coterminal angle, is equal to theta, which is the original angle, which is the reference angle, plus 360 degrees times n. N can be integer number, meaning a positive or negative number. Can be 1, 2, 3, negative 1, negative 2, negative 3. And the special case when n is equal to 0, you get back the same angle. The sine, cos, tan values of coterminal angles are always equal. This is the whole point of this lesson. Coterminal angles, they have the same sine, cos, and tan.
No question.
Okay, we are supposed to find the coterminal angles, two of them, for, let's say, 75 degrees. I know the coterminal to 75 degrees are 75 plus 360 times any integer n. Now, as I mentioned before, the answers are not going to be unique. So I'm going to pick for the first value n to be 1. Then it's going to be 75 plus 360 times 1, which is 75 plus 360, which is going to be 425? 35. That's the first one. The second one, I'm going to pick n equal to negative 1. So I'm going to say 75 plus 360 times negative 1, which is 75 minus 360, which is going to be negative 285. So the two coterminal angles are 435 and negative 285 degrees. That's it. For the second one, I'm going to do the same thing. I'm going to say the first one is 120 plus, if I pick n to be 1, so plus 360, which is going to be 480. The next one, I'm going to use n equal to -1. Again, you can pick n equal to 2, n equal to 10 if you want. Doesn't matter. The next one, I'm going to pick -1, so it's going to be 360 times -1, which is going to be 120 minus 360, which is -240 degrees. Now, if you use your calculator, go ahead. Try sine, cos, and tan for these two angles. You will see that they are equal. But remember, the sine of 435 is equal to the sine of -285, not the sine 435 equal to tan -285. No. And the same thing for these two angles. Okay, the first part of the example asks to find the radius if the terminal point is 8, 6. This means graphically that if this is my circle, x is 8 and y is 6, so let's say, the point is represented here. This one is going to be my x value, which is 8. This is going to be my y value, which is 6. To find the radius, I use Pythagorean theorem, and I'm going to say r squared is 8 squared plus 6 squared, which is going to be 64 plus 36, which is going to be 100, which is r squared. To find r, I take the square root of both sides. I get r is plus or minus 10. Again, square root of any number is plus or minus the square root of that number. Now, since the radius is the distance and can't be negative, so I'm going to drop the -1, so the answer is 10. So that's the radius of this circle. Now, to find the measure of the angle, I can either use sine, cos, or tan. I'm going to use sine, and I'm going to say sine theta is opposite, which is 6, which is a y coordinate, divided by the radius, which is 10. Now, if you use the inverse sine, you will find that sine, the theta, is going to be about 36.8. So when you have x and y both positive and in the first quadrant, the answer is easy to find, okay? The problem is when one of the coordinates, x, y, or both of them are negative. Then how do you do this type of questions? Remember that you have to give me the positive angle. You can't give me a negative one. Okay, now we are going to talk about when the coordinates, one or both, can be negative. So let's do part B, which is -5 and 12. So again, I'm going to draw my unit circle. Not unit circle because the radius is not 1. So it's a circle. And then the point x is -5 and y is 12. So let's assume this point represents -5 and 12. This is my terminal arm. And I know automatically this is my angle. But I have to find this angle. To do this type of problem, my advice to you, find the angle theta, which is the reference angle, which is going to be in the first quadrant here. How do you find the angle? Is very simple. Forget about the sign of the coordinates. So just assume that really P prime is another point is 5 and 12. Forget about the negative or for x or negative for y. Find the angle using these coordinates, 5 and 12. Okay? To do that one, first I have to find the radius. So I'm going to say r squared is 5 squared plus 12 squared, which is 25 plus 144, which is going to be 169. Take the square root of both sides. I'm going to get r is plus or minus 13. The same logic, distance can't be negative, so radius has to be positive, so -13 is rejected. So the radius is 13. Now I can use sine, cos, or tan. But remember, P prime, I'm using the positive x and y. So I'm going to say sine theta is 12 over 13. Remember, sine is y over r. Y is 12. Now, if you use your calculator, what is theta here? Okay, if you use the inverse sine, you get angle theta is 67.38 degrees. Now, this is the part. I look at the original point, minus 5 and 12. Where do you think is this point? Is it first, second, third, or fourth quadrant? The second, because x value is negative, so it has to be in this quadrant. To find the point corresponding to the terminal angle, I'm going to, this is my reference angle, which is 67.38. I'm going to reflect this point onto y-axis to get this point, exactly the same, negative 5 and 12. Now, how do I represent this angle? Is I'm going to compare it with this line, x-axis. Either I'm going to add to 180 or subtract it from 180, this angle, or I'm going to deal with 360, which is one full rotation. In our case, really, I want 180 and then subtract 67.38. So what is 180 minus 67.38? How much is that angle?
112.62.
So your angle is 112.62 degrees. So let's do the last one, which is negative 2, negative 5. I said whenever you get a point, if they have the sign x and y, just drop the sign. So let's say we are going to deal with the point P prime, which is 2 and 5. Again, this is my circle. Point 2 and 5 is going to be somewhere, let's say here. This is P prime, which is 2 and 5.
It's lagging.
Now, so this is the point P prime 2 and 5. This is, as usual, going to be my y coordinate, which is 5. This is my x coordinate, which is 2. I have to find the radius. I'm going to say r squared is 2 squared plus 5 squared, which is 4 plus 25, which is 29.
Mr. Shah, are you just repeating the one that we just did?
Yeah.
And then I take the square root of both sides to find r. So I get r is equal to plus or minus square root of 29. Again, radius can't be negative because it represents distance, so negative is dropped. So the answer is radius is square root of 29. Now, again, we are dealing with the point P prime, which is here. I know that sine theta is y coordinate of the point, which is 5 divided by radius, which is square root of 29. If I simplify this one and use the inverse sine, I'm going to get theta equal to 68.1 degrees. This is point P prime. This is not point P yet. Now, if I look at point P, I see that the x is negative because x is negative 2, and y is also negative, negative 5. So I look at my quadrants. The only quadrant that x and y are negative is quadrant 3, which is here. Now, this is my P prime. To get a point on the third quadrant, I'm going to reflect this point about the origin to get this point, which is P. This is P, which is negative 2, negative 5. Now, I need this angle now. This angle. This is the one that I want because it's positive.
Which angle do you want?
The angle that I shown here. This is the angle with the positive x-axis. okay, going
You
counterclockwise.
want that angle at this one.
Yeah.
Okay.
Now, to find this angle, I know this angle, the reference angle, is going to be 68.1. So this means the opposite angle, which is right here, is going to be 68.12, this angle here. Because this angle and this angle, they are opposite, these two. So I'm going to add 180, which is this one, plus 68.1. So I'm going to say really the theta is 180 plus 68.1 degrees. And what is 180 plus 68.1? 248.1. Okay, the last question. You have a terminal point, again, xy, which is shown here, is on the unit circle. So we know that the circle, the radius is 1 because it says unit circle. And it forms a 120 degrees angle in standard position. So this is your 120 degrees angle in this counterclockwise rotation. The question is that what is the coordinate P? Meaning, tell me what is x, what is y of the point P. Okay, the first part, I have to find x and y. By definition, we know this is a unit circle, so we know that y really is sine theta, which is sine 120. Now, if you use your calculator, what is sine 120? 0.86. And for x, we know that x is cos theta. Remember that sine theta and cos theta, they are going to be divided by the radius, but this is a unit circle, so the radius is 1. Now, cos theta is really cos 120, and cos 120 is positive or negative? Positive. Positive? Okay, so your cos 120 is negative 0.5. Remember that x and y is going to be 0.86. Sorry, negative 0.5 and 0.86. So that's going to be the coordinate of point P. Okay, the last part of the problem, how do the coordinates of the point on the unit circle relate to the trigonometric ratios? Very simple. If this is the unit circle and this is the point PXY, we said before that if this is the angle, we said that sine theta is equal to opposite, which is y, divided by radius, which is r. But the unit circle, r is 1 because it's unit, so this is 1. So you get y here, so you can say that y really is sine theta, and the same way, x is cos theta. So this is how the coordinate of any point on the unit circle relates to trig ratios.